Session 4.2 is going to be talking about hydrogen station scaling up. We also have some questions from yesterday. I think this panel will also be able to answer some of the questions from yesterday. So without further ado, I'm going to hand this over to Jeff.
Good, thank you. Thank you, Yachin. If you put the first slide up. Okay. So, here we are. This is kind of a wrap-up panel on hydrogen. I'm Jeff Surface. I'm thrilled to be here with you. And this is a lineup of our panel. First of all, I am Executive Director of the California Hydrogen Business Council. We have a table downstairs. I welcome you to look for the fact sheet that the California Fuel Cell Partnership and we put together on fuel cell electric buses, and to pick up a brochure that has some information on membership. We would like to have more transit agencies who should be evaluating fuel cell electric buses anyway to become a part of our market group. We have several market sector action groups. One of them is public transport. We know that the ICT has changed your world. It's changed the need for you to evaluate the alternatives for zero-emission buses. We, of course, firmly believe that fuel cell electric buses are one of the options you have to be evaluating and considering, and this panel will focus on infrastructure because we've already discovered and talked about some of the elements here. First of all, this is the panel. You see their position titles: Chris Kretz from Air Products and Chemicals. I'm not going to further introduce them as we proceed. Ryan Erickson from General Manager of Strategic Development for Trillium, the Loves Company. You've heard from each of them already, but their presentation now is different. It's oriented towards the infrastructure development. Steve Szymanski from Nel Hydrogen, Director of Business Development. Jeff Allen, who Director of Market and Business Development for NICE America. And Al Chiaffi, Business Development for Plug Power. So if I can successfully advance. So you've heard already that the fuel cell electric buses are essentially proven. They haven't matured completely yet, but they're proven. And I love the data coming out of AC Transit that demonstrates that and updates us virtually every time we have a meeting. So we're not going to talk about that particularly. Sorry, my advancing is, yeah, thank you. So this session, having already with Jamie's session yesterday, talked about the cost of hydrogen and that issue, and it is an issue that needs to be and is being addressed. This session will really talk about developing infrastructure at scale, much like the last session did for battery electric vehicle charging. So we're going to talk about how that scale is developing here and elsewhere, that there are multiple pathways, we have multiple people. You notice none of the people on our panel are transit agencies, for right or wrong. These are people who are delivering equipment and services to you as potential fuel cell electric bus users. The production of renewable hydrogen is developing. It's very important. And as an organization, we have committed, as the Hydrogen Council, Worldwide Hydrogen Council is committed to zero carbon transportation fuels very soon. What's the year, Jamie? 2030, I believe, the Hydrogen Council. And then the technology is developing. You're going to hear several people developing their or telling you about their view. So we're going to proceed with the first speaker. We want you to hear enough in this session to become convinced that fuel cell electric buses have to be part of your evaluation of how you meet the ICT regulations. So first, on my left is Chris Kretz from Air Products and Chemicals. Chris? Okay, like that.
Good morning, everyone. Thank you, Jeff, for having me on this panel. Thank you to ARB for allowing us to have this forum to talk about hydrogen and scaling up hydrogen for transit agencies. We're going to try. Okay, great. So getting started, a lot of you may be wondering, if I was even thinking about hydrogen and fuel cell electric buses, how would I get started? There's a lot of folks here who can help you understand the buses, but just from the bus perspective, you really want to understand about the fuel cells, about the fuel cell electric bus, about the hydrogen, and know that there are a lot of agencies and companies who are willing to help you get started. And so all you really have to do is contact, from a hydrogen fueling perspective, contact folks on this panel and some of the other panels you've seen. And from a bus perspective, there's some folks outside. But we have the information that you need. It's pretty straightforward. I would venture to say it's perhaps more straightforward than doing battery electric buses, but you can tell us after you've come to talk to us. But once you've made the decision to do the evaluation, you really want to start thinking about, do I just want to do a little demo, a bus, a couple buses? Do I want to do 5 buses, start with 5 buses or 10 buses? And so we can talk through some of those things with you and talk through the infrastructure piece of it. I do want to reiterate the SARTA in Canton, Ohio, has a borrow a bus program, and I put the link on there as well. So if you want to take a look at that, it might be a way for you to just get one on site. We can put a mobile fueler there. You can try it out for a week, and you're good to go just to see what it's like. So that's the bus piece. When we talk about hydrogen supply, I did mention yesterday that there's a variety of options for hydrogen supply. But if you're in that getting started category, we and others have something called mobile fuelers or temporary fuelers that we could bring to your site. Ours require minimal to no utility. In California, it would really require no utilities. There are solar panels on the roof. It's got a dispenser on it. It's got your hydrogen. And you can bring it to your site and hook it up to a grounding source, and you're pretty much set to go. And it can't fuel a lot of buses. It can't fuel a whole fleet of buses, but it can get you started. And we've used this setup. The picture shown at the bottom is what was used at AC Transit before they had their full permanent station. And it's just a series of mobile fuelers and trailers connected together. We have something similar at the port right now for a 6-truck demonstration. And so this is a great way to just sort of get started. The total cost is fairly low. The hydrogen cost in this kind of setup is high. I will be frank about that. But if it's meant to just get you started and try it out, it may be a good way to go. And this would be outdoor fueling with minimal site prep. Then from a scaling perspective, that's when you start to get a little more complicated. But again, I would venture to say not as complicated as some of the things I have been hearing for other alternative technologies. There are options, though. So that's where a dialogue needs to start. I heard a lot of discussion earlier and yesterday about planning. Yes, it requires planning. But we and others can help you do that by just walking through what the options are. And the options for hydrogen are liquid hydrogen or making the hydrogen on site, whether that be reforming, electrolyzer, or even trigeneration, or pipeline hydrogen. And there is gaseous hydrogen, much like we talked about in the temporary supply, but that's probably one of the more expensive routes to go in terms of scaling up. And I just want to point out some of the slides some of the pictures on the right. That's a liquid trailer. That's what comes and delivers liquid to a site. Below it is a liquid station, pretty straightforward. Then below that, in the middle, is a reformer container. And then to the left of that is the Shell Torrance station, which is a station that we built for Shell some time ago, and it is a pipeline station. So it's not anything exotic. It's just fueling as you would see it in Shell Torrance. And then the last picture on the left shows you some typical pipeline setup. So in terms of what we feel is one of the best technologies for transit agencies and for scaling up, and we're a bit biased because we provide this technology and we have the supply, but liquid hydrogen, delivered liquid hydrogen to a site is one of the most versatile ways of providing hydrogen to a transit agency. And so what I've shown here is a picture. You've seen this picture previously. This is the station that Trillium and Air Products are putting into Orange County. It is Air Products design and key equipment, and it's designed for 10 buses initially, but this can easily fill 20, 30, 50 buses. And then with minor modifications and some added equipment, it can go to 100 or 150 or 200. As long as you have the footprint to put in some of that equipment, additional equipment, you can have a station that's expandable up to 200 buses. And the nice thing about that is it's an additive cost to you to scale up, not a multiplicative one. And I think that's an important point to think about as you're considering technologies. The planned on-stream for this is spring of 2019, so it's in progress and being built, and looking forward to seeing that online. Sorry about this. Thank you. And if you're just looking to know what the components are of this smart fuel station, it's pretty straightforward. It's a liquid tank over on your left. Just wanted to make sure I had the orientation right. Liquid tank over on your left, some compressors over to the right, vaporizers, some gaseous storage, and dispensers. And it's pretty similar to what you might see for a CNG station. Very, very straightforward and readily expandable. And if you think about a pipeline station, it actually has very similar building blocks. Again, I think people get a little nervous, pipeline, that sounds complicated. And really it's not. You put in the pipeline, that's probably the most complicated part. I won't argue with you there. And then you have a purifier on the end because pipeline hydrogen is not at the right purity for what you might need. But then everything else follows from that, very similar to a liquid or a gaseous station. You have compressors, you have gaseous storage tubes, and you have dispensers. And so it's pretty straightforward and can meet the needs of, easily meet the needs of 25, 50, 100 or more buses. Another option that Air Products offers is we have hydrogen generation technology at a small scale. So this is a smaller version of what our plants are in Wilmington and Carson. And the nice thing about that is we sell it in different modules, one for 20 buses, one for 40 buses, one for 60 buses. And these are in containerized packages, and they could be installed fairly readily because of that. It will end up taking up more footprint than a liquid station, but if you have that interest in generating on site, that is an option for you. And this can be done via on-site generation, can also be done via electrolysis, which one of our panelists will speak to you about as well. And then finally, the slide I'll leave you with is one I showed yesterday, but just to kind of reiterate, some of the considerations you need to think about are scalability and footprint. And what this shows you is, depending on what you have at your site, if you've got a decent amount of real estate, you probably have more options. But if you have limited real estate, you really need to think carefully if you want to scale up to larger volumes and amount of buses. And again, that's where delivered liquid really becomes a nice choice. And that's it. Thank you very much. Okay.
All right, good morning. Ryan Erickson with Trillium. This is the third time I think Trillium's spoke here, so I'm going to just say that we're with Trillium, and Trillium is owned by Loves. Can you advance the slide for me? Thank you. So you can go on to the next one. Saw this yesterday as well. You know, what I'll say is, I guess that maybe the difference between Trillium and some of the other people that are up here, but maybe not so much as well, is that we're not equipment providers or equipment manufacturers, I should say, and so we will work and look forward to working with every company that I'm up here with in maybe some combination that's different for each customer. You know, we're working with Air Products pretty much exclusively on the Orange County Transportation Authority project, but maybe we'll work with Nell on, you know, the next bus project, or maybe it'll be a combination of, you know, all three of us working on the next project. And so that's what we feel we kind of bring is just, you know, bringing that experience of you know, fueling, I think I mentioned yesterday, about 80,000 gallons of CNG, you know, per year to transit agencies, 13 million gallons of diesel a day at the Love's truck stops. Bring that experience and bring the partners together to provide the right solution for each customer. Next slide. Jamie mentioned yesterday the PARSE acronym. Maybe not the world's best acronym, so we'll have to make them work up a better one. But it at least gets the key points across, which is price, area, redundancy, speed, and I've changed the E to entry effort. I'm not going to talk about price of fuel even much today because we talked about that yesterday. And I'll talk about entry effort kind of on the next slide. But you know, our goal and what we think is needed for transit agencies is speed of fueling of a roughly 5 kilograms per minute. If you remember, again, the fuel cell electric bus is going to be about, you know, 1.5 to 2 times the fuel economy of what you're used to seeing with diesel or natural gas. So you know, 5 kilograms per minute is kind of the same as, you know, getting up into that, you know, 8 to 10 gallon per minute flow rate for your traditional fuels. So we think that'll give you the same kind of experience you're used to in that 5 to 10 minute fueling experience. Redundancy, I think that's really a key component of the hydrogen solution, and you know, probably even most specifically with the liquid hydrogen solution that we think is one of the better options on kind of constrained sites at large volumes. You put in the amount of storage, like the tank that Chris showed. You put in tanks so that you have maybe about 3 days worth of usage stored. So again, if there was, you know, bad weather, if a truck delivery couldn't make it in, all those types of things, that you've always got at least 3 days worth of storage. And I would say at least 3 days, so it's 3 plus. So that's one, you know, good method of redundancy, something that you wouldn't have with maybe some of the, you know, other, like with, you know, it's hard to get 3 days worth of battery electric storage. We, you know, size the equipment so that, you know, if it turns out you need 4 lanes and that's 20 kilograms per minute, you don't put in one 20 kilogram per minute pump, you put in 4 or 5 kilogram per minute pumps. That way you've got your full 20 kilograms when you need it. If a pump goes down, you're down to 15, you still totally make it through your pullout with no issues there. Instead of a 6-minute fill, you went to a 7 or 8-minute fill that night. So another good method of redundancy. And then the amount of power that's used for these types of facilities is not that much different than, actually I would say it's, for a liquid hydrogen system, it's less than a CNG station. So you can have a very standard size emergency backup generator that can power the entire facility if you lose power. And then the square foot or the amount of space that these systems take, you know, I think that we can provide systems that will take somewhere between 5 to 15 bus stalls. And so I give it to that way, so you know what you're losing, you know, where you have to move your contingency buses away from or whatever. But you know, the system can go pretty much anywhere on property. It doesn't have to go in any particular location. It's whatever's most convenient for your operations. And you would lose, you know, somewhere between 5 and 15 bus stalls. There are ways to take up less space, maybe underground, you know, systems, and I'll let other people on the panel talk a little bit more about that in a second. But all right, good deal. Just real briefly, you know, there's a lot of repetitiveness here at this point, so I'm going to kind of cruise through a few slides probably. But you have the option of basically having hydrogen delivered in, gaseous or liquid, or you have the option of producing the hydrogen on site, electrolysis or SMR. We've talked about it a little bit earlier, talked about it a little bit yesterday, so I won't go into it a lot more than that. Once you do that, there's kind of the compression, storage, and dispensing that's roughly the same regardless of your choice. If it is delivered from off-site, the way it was produced is going to be pretty much the same at a smaller scale, that same electrolysis or SMR systems. So, can you go back a slide maybe? Thank you. So the entry effort, and I don't want to spend a lot of time on this. In fact, you'll see the same exact slide from Air Products there. One of the things I do want to say, though, is that unfortunately, when doing hydrogen and going from a demo fleet to at scale, it may not make sense to have the system on day one that you want on year 2 or year 10. And it might make sense instead to do kind of an entry level effort that's maybe gas tube storage that comes in and out on a daily or several day basis. And that might not be the solution that you use after your first 3 buses have kind of proven themselves and you've decided, okay, it's time to start transitioning the fleet, and my next order should be 10 or 15 buses. So you might have a different solution for the first months and or year or 2. And I think that should be considered okay. I think that there's pretty low cost options to do these kind of lower cost entry systems like this. You do pay more per kilogram for the fuel, but the system itself is pretty easily installed. Not a lot of cement and civil, mechanical, and electrical work that's needed for those systems. So here's just a couple different examples of some systems. Again, hauling in gas is probably one of the more common ways to do it. There are some new vendors or new OEMs out there that are producing new equipment that might be pretty cool, like solar reactors and all that kind of stuff. So let's see if I can. And a couple more systems as well. You can get, again, these storage tube systems where they are fully self-contained and they have all their power on board. So they're really quite simple and easy to use. Next slide. Thank you. All right, so just a couple examples for scale up. This is for a customer that is not a customer yet, but certainly somebody that we've been talking with very closely, at California Transit Agency, where they have a fleet of around 180 buses on a particular site. It's a very small site, very tight site. So they have slightly shorter routes, so they maybe don't run quite as many miles as like OCTA does per day, per bus. So they would be able to do 180 buses. And again, that's 180 buses total with their spare ratio, fueling maybe 150, 155 buses a day. And they can do that with around 3,000 kilograms per day of hydrogen. That would, our solution there would be to put in 2 liquid hydrogen storage tanks and associated compressors and vaporizers and dispensers to meet their needs. Take up maybe around 10 bus stalls. And you can see this isn't even, this is, maybe you can't tell what you're looking at. The 2 long things are the tanks, and they're horizontally kind of situated. They're about 40 feet long each. Depending on where on property and what the zoning requirements or the permitting requirements would be there, you might even be able to do those tanks vertically. Chris had a picture of a vertical tank, takes up a lot less space, but it is taller, and so maybe you don't do that right up against the edge of the property. But so in the worst case situation, we think we would only take up about 10 bus stalls. And we think that that station would cost them around $6 million, and that would fuel their entire fleet of 180 buses. And that's a 5 kilogram per minute fuels, fueling multiple buses at a time. Basically the same exact operations that they have today with diesel. And you've already seen the OCTA slide. I won't spend a lot more time on it, other than to say that that site we took up around 8 bus stalls. Again, we think we could double that capacity and not have to take another 8 bus stalls. That's the scalability that we're talking about here. That was a $4.7 million project with CARB funding. That did include 3 years of warranty and maintenance as well. So the actual CapEx costs, if we were to come in and build that same exact site again without the warranty and maintenance built in, would be less than that. And then, like I mentioned yesterday, and Bill Zobel mentioned yesterday, if we had to expand that, maybe double its capacity, it would not be another 4.7. It wouldn't be another 3.7. It would be a much smaller number than that to double that capacity. That's it. Thank you very much.
Great, thank you. I'd like to again thank CARB for putting on this workshop. I think this is a really, really important activity for the whole industry. I'm gonna focus on electrolysis as a scalable hydrogen supply solution for transit fleets. And just this first picture, I just want to make 2 comments on it. I'm going to talk about centralized production of hydrogen from electrolysis and how that can work into a transit model. This is a picture of a big electrolysis plant. It's produces about, or it did produce about 60 tons per day of hydrogen. Each one of those cell stacks produces about 1 ton per day. And so the picture shows kind of the scalable concept of electrolysis, because you've got these multiple cell stacks that produce the hydrogen that you can simply gang together to give you the scale you need. And for reference, 60 tons per day, that's enough to supply about 3,000 buses. So when you talk about being able to do hydrogen production at scale for transit applications, this has been done. Next slide, please. Just really quickly, our company is, we're based in Norway. I work at the US subsidiary in Connecticut, where we produce PEM electrolyzers and have for more than 20 years. But we also have our alkaline electrolyzer factory in Norway and a hydrogen fueling station factory in Denmark. So we actually produce not only the electrolyzer equipment that produces hydrogen, but also the fueling equipment, both 350 bar and 700 bar fueling equipment that can be installed at your fueling sites. There we go. I got to point it to the left, I think. So, just really quickly, these two cartoons just kind of show the two types of electrolyzers that we produce. Fundamentally, they do the same thing. The inputs are electricity and water. And so if your electricity is coming from, green carbon-free sources, then your hydrogen is, what we like to refer to as green hydrogen. Both technologies that we produce, have kind of their pros and cons in terms of how we choose one over the other. But fundamentally, we offer a complete portfolio of electrolyzer capacities from very small to very large, as I showed in the first picture. So, the first thing, I mentioned the modularity of electrolysis, and I'll use the example of the electrolyzer we're installing at Sunline Transit as an illustration. So we're installing an electrolyzer that will produce a little over 900 kilograms per day of hydrogen at that site, enough to support about 26 buses. And that particular electrolyzer system has 8 modules installed into it. So there's 8 cell stacks, and each cell stack has a dedicated rectifier to provide the power, the DC power to drive the stack. Now, I could install half as many modules and get a 450 kilogram per day electrolyzer, and then upgrade that in the future. So when I look at how could I grow a system like this, where you start with less capacity and add it, you can do it very cost effectively, because the balance of plant is already installed, and now you're simply adding kind of internal modules to that. So to go from 450 to 900 kilograms per day, it's less than 50% of the initial capital cost. So that's just kind of one of the ways that this technology, you can use it to kind of scale on site more cost effectively. There we go. I thought I had it. So just to kind of introduce the concept of how we think centralized production can be a cost-effective model for transit fleets. Basically, the picture at the top shows a 50 megawatt electrolyzer producing about 25 metric tons of hydrogen per day. Now, that's enough to support about 1,000 transit buses, maybe 500 Class 8 trucks, and maybe 40,000 cars. The difference is, for cars, I need more of a network to support those vehicles. So I need kind of multiple fueling locations, whereas for transit and truck type fleets, I can have kind of depot fueling where you're fueling in one location. So you get better utilization of the equipment, and you get more efficient kind of management of the hydrogen supply. There we go. So just to kind of illustrate that a little bit, okay, the curves at the top you've seen before, I think, where the cost per bus goes down with fuel cell infrastructure as you increase your fleet size. And just to kind of illustrate that, along the bottom, these are our kind of projections, and I'll apologize in advance for the NOK currency. That's Norwegian kroner, but 85 NOK, as we say, is it's a little over $10 a kilogram for the conversion, just to help. But as you go from 10 to 50 to 150, you have a nice reduction in the dispensed cost of hydrogen for your operation. So as we scale, those kinds of projections match up pretty nicely with the curves above. There we go. So just to kind of illustrate this, so in Norway, we are building out infrastructure to support transit fleets there. And the idea is, centralized production with gaseous distribution to, kind of a perimeter of fleets. And, we're taking advantage of some, high pressure trailers that are allowed in over the road there to help make it an efficient and cost-effective delivery solution. There we go. So just to kind of show you kind of how this scales. So for a relatively small fleet, say 30 buses, what we're showing is kind of how the equipment would lay out. So we've got this purple box that kind of shows our fueling equipment, on site. And then next to that is basically a trailer lane for dropping off trailers of compressed hydrogen. The dispensers can be remote from the rest of the station equipment. We say up to 100 meters away from your primary station equipment. So for this model here, we're talking about maybe 60 square meters to support 30 buses, just with this drop and swap kind of delivery method. And let's see how this scales up to 150 buses. Now, the way that we address the higher capacity is with more trailer lanes. So you would always have a couple trailers hooked up and providing hydrogen, and you would have maybe a third lane that's always available for doing the swapping. So now to go from 30 buses to 150 buses, we go from roughly 60 square meters to 200 square meters. And again, you can have multiple dispensers set up remotely from the primary equipment site. There we go. So just to kind of give you a visual, this is at a Oslo facility that we're working with, where we're scaling up from, right now today it's about 250 kilograms per day of capacity, 10 to 12 buses. The footprint today is about 350 square meters, but that's where we have the electrolyzer on site. Now the new solution is going to be this centralized production using low-cost hydropower, which they have in Norway, and we're going to be supporting up to 150 buses, which is about 3,000 kilograms per day. And the footprint goes from 350 square meters to 200 square meters in terms of the area that we need, because we're doing this drop and swap model. And the cost goes from about 110 NOK per kilogram down to about 50 NOK per kilogram. So increasing the capacity by a 10x and cutting the cost more in half. And again, that's enabled by these kind of two key elements at the bottom, is kind of this high pressure drop and swap technology, along with the centralized production facility of an electrolyzer. And so just the last slide I wanted to say is that today, when we compare hydrogen for fuel cell buses relative to diesel, we're already very close to cost parity on a $1 per mile basis. And this is just some numbers here that you can look at when the slides get distributed. But Ryan talked yesterday about getting down to $5 a kilogram. If we can get down to about $5 a kilogram, we are at cost parity with diesel buses on a $1 per mile basis. And we think that is very achievable today. Diesel hybrids and CNGs, a little bit more scale needs to be realized in order to get the cost down to cost parity. But the thing that's very encouraging is the kind of cost trajectories we see, and how right now we're already within striking distance on diesel buses. And that's it. There we go.
Good morning, everyone. I'm Jeff Allen for NICE America, and thank you for the invitation from CARB, various other industry folks, including Jeff and Jamie Levin and various others. Wanted to introduce you and talk about technology vision for the future. So a number of you in the bus community and transit agencies have heard about us indirectly when someone's out talking about underground technologies. So I want to introduce this technology. One thing that's interesting, and this clicker's not working. So I grew up in Texas, and of course everybody says everything's bigger in Texas, but China makes Texas look tiny. So want to talk a little bit about that. NICE America is actually, if I ever get to the slide, a clean tech incubator for China Energy. China Energy is the world's largest power producer. We have 350,000 employees, the largest coal miner in the world. We're vertically integrated, so we have ports, rails. We also are the largest wind producer in the world. And I like to make the joke that we're also the world's largest company no one's ever heard of. So one of the other things that's quite interesting, Al asked a question about curtailed wind yesterday, and I think it was a couple hundred gigawatt hours or something like that. So China Energy actually has over 10 terawatt hours of curtailed wind in China. And right now it's out in the middle of nowhere, so we're trying to figure out what to do with it. And of course, utilizing hydrogen. Unfortunately in China, liquid hydrogen's not approved for transport, so you're stuck with gaseous hydrogen, which the distance away where this curtailed wind is so far, that gaseous is not practical. So you really need liquid to take care of that if you were to utilize hydrogen as a solution. So who is NICE? NICE is a group of researchers, in excess of 400 researchers over in Beijing, another 20 in the US, 150 over in Schwabisch Hall outside of Stuttgart, Germany, where we did a joint venture with a CIGS solar company. We are the clean tech incubator for all of China Energy. So one day I'll be working on new materials based on coal byproducts like plastics. Others I'll be working on natural gas propants. Other days I'll be working on hydrogen, carbon capture, all of the above. So we have a very wide mandate, including distributed energy, so new battery materials. It's pretty wild, a little overwhelming, but pretty fun. So, so we're working on various things. It was originally constructed 10 years ago as foreign experts. So a lot of our DNA and executives and team on the senior side comes from GE Global Research, Air Products, also Dow. We have a lot of distinguished folks and tremendously experienced within our hydrogen team here in the States. We have one of the leaders who set up a lot of the stations for Plug Power, also one of the leaders who set up a lot of the stations for Linde. So we have tremendous experience base in the team we're working with here locally. So, what is China doing on hydrogen? If I can get to the slide. There we go. So China is very ambitious in the desire to succeed and really sees hydrogen as the better solution over battery electrics. Obviously, you heard from various folks, Chinese battery bus manufacturers and also Shenzhen team who's done fantastic work. But you see the incentives in China actually diminishing on battery electric and increasing very actively in case of hydrogen right now. So a lot of folks, and as you probably saw recently, a company called Weichai that is one of our sister state-owned enterprises made a very large investment in Ballard. And they're also making other investments and ourselves. So there's a lot of tremendous activity in the hydrogen space currently occurring over in China. There's various 7 regions around China working on it. To give you a frame of reference, so the county of LA has 4,700 buses. New York City has 9,700, roughly. Beijing has 29,700. So, as I said, everything's bigger. One of the other things that's interesting about that, in the case of the US and Europe in general, most of the focus initially on hydrogen was in the light duty sector. China's going fleet first because they want to push the molecules and get to economies of scale very quickly. So they're extremely aggressive in primarily buses, not so much in heavy duty, meaning trucks, but definitely in the case of buses. So there's a lot of groups working on that right now. As you saw when I briefed you on who China Energy was, we have tremendous opportunities for production. In fact, as I mentioned, we have a tremendous amount of coal-fired power plants. If we brought one of those online to make production of hydrogen, obviously we need to put CCS in it because that wouldn't be acceptable to any of us, and we're not going to ship into the US, just in case anybody has such an odd question. That would provide enough hydrogen for 500,000 cars. So scale of everything is much, much larger. And we're looking at production over in China very aggressively because China is fully committed to climate change and the Paris Accord. So we're aggressively looking into that space, including both from our wind resources and assets, also our coal-to-chemical plants and our coal-fired power plants. So a lot of space, a lot of activities, and as you think about it, and even when I went to EVS 30, which is a battery conference in Europe for EVs, they were saying, all of the auto manufacturers over in Europe were saying that basically China will dictate the future of EVs. Same thing goes, and that's surely purely based on economies of scale. So to give you some perspective on what we're working on, if the slide would change. So our aspiration, very much consistent with Ryan, and we've done a deep techno-economic analysis. Obviously, these production numbers we're showing are more on our internal production capacity over in China. So, but as we've consulted and we've kept a very low-key activity, so the people who we want to know about us here in the States. Others we have worked through, so some of the transit agencies have heard about this concept of underground. That's actually us doing the technology there. So we see at the industrial gas companies and also our internal production capability, we foresee the future of $3 per kilogram. And if you now look at the rest of the bill, how it adds up, with our target of a $4.50 per kilogram pump price. So very aggressively as far as that goes, and we foresee a future where that is definitely possible, and are working on principally the production over in China and also the refueling here in the States and in China. So what are we doing about that? Within China Energy and NICE, we have a sister subsidiary called Shenhua Hydrogen. They are committed to building 200 to 300 hydrogen refueling stations, very large capacity refueling stations, and it's all self-funded by us. So we're committed and very aggressively pushing forward that. They're all going to be 1,000 kilograms per day or more. We're also looking at molecule production. Within the NICE portfolio, our team over in Beijing is working on gaseous infrastructure equipment development, so stations for gaseous, since liquid is yet to be approved. We're also working on codes and standards and driving those codes and standards so that liquid can be approved. And you can also start to consider reduction in footprints based on safety and being smart and standing on top of all of the expertise that's been created throughout Europe, the US, and Japan on safety standards and protocols for hydrogen. So we're incorporating that and pushing it forward as fast as possible in Beijing. Here in NICE American, we're located in Mountain View, immediately adjacent to a small company called Google, in case you've never heard of them. We're working on liquid development. We have 20 folks in total. About 5 or 6 of us are working on the hydrogen team. We have some really interesting partners that we're active with. Also, of course, and you probably saw this in the top right, we're a member of the Hydrogen Council on the steering committee level at the invitation of Air Liquide. Come on, change the slide. Okay, so as I said, we're building 200 to 300 hydrogen refueling stations. Our first step into that is in a city called Jiangsu, Rugao. It is on the outskirts of Shanghai, and we're in the midst of building that station right now. It will be fully commissioned, expected spring of 2019, and the nameplate capacity is 1,000 kilograms a day. with 500 kilograms of on-site storage and the remainder being drop and swab. The equipment utilized for that is principally Air Products equipment. And so you can see it's a dual pressure capacity. So it's principally for local transit agencies, but definitely for consumers, although there's not a lot of light-duty vehicles in China currently for hydrogen. They're in development by various companies like SAIC, BAIC, Great Wall Motors, and various companies that are producing those right now. So, as I said, our vision at NICE America is actually a full station transformation. We are pushing underground technology. As Ryan and Steve and Chris said earlier, what this means is if we can implement this, and we're in technology development, so it's not done today, and I will not try to sell it to you yet today, but this is our vision, what we're implementing, and we have tremendous partners that as we get a little further forward, I'll talk about the names, but the entity we're principally working with where we're getting our liquid hydrogen pump is utilized on virtually all of the large heavy-duty truck LNG systems. So it's extremely well known and very trusted in the industry. We foresee underground as the future. The beauty of it is now you can take a station that has 8,000 kilograms capacity or much, much larger, and now have roughly, for an 8,000 kilograms a day, roughly a footprint above ground of about 20 by 10. Because all you have is hydraulics, control systems, and a vaporizer. Nothing else. Compressor's gone, cascade tubes are gone. All you have is a tank and the pump and tank concept. So the beauty of that is now you have a pump and a technology where you have zero boil off. So if you check the boxes and look at what is the required transformation to enable, independent of the cost, obviously, if you look at the station specifics, what are they? You want something that's high reliability. A lot of it today is good equipment, but it's in the early stages. And now as this industry matures, you'll see the transformations. And the goal for us, both from a footprint standpoint, from a user standpoint, and also a performance standpoint, is the same as your diesel or LNG based buses. That is the goal and the vision we have, and we're driving towards right now. Further, profitable station, obviously dollars per kilogram and very large capacity, and zero boil off, so it tremendously improves your OpEx. Minimal footprint above ground. Because we eliminate cascade storage and the like, we're doing direct fill, very fast fills. Our pump capacity is targeted at 230 kilograms an hour, and because it's in the cryogen at all times, you don't have a remote location where you're mixing between gas and liquids in the pump, and therefore slowing down the speed of pumping.
Can you wrap?
Yeah, wrap up. Okay. I would if the slide would move. So I think I've said all of this. Our initial iteration is for a bus application, so 35 MPA dispensers. Above ground, our technology development timeline, we're going to have our equipment complete and start in testing of Q3 this year. We're going to look to do a demo station middle of next year. Can't guarantee it will be in the States, but more than likely given the liquid limitation. So we are considering and exploring and thinking about who we might want to partner with to do a customer-sited demo. We're also, of course, going to have Made in USA so that it meets the needs of the local transit agencies. One last thing I'd like to say, and this is something we're working on in conjunction with California Fuel Cell Partnership, is we think this transformation in the vision is the future of the entire industry. We'd like to make a call to arms of people who would like to partner with us and work with us to really deliver on this vision. Whether the leading light-duty folks are very much believe in this, but also as I talk to various people, including some on this panel, everybody sees the vision and agrees that this is the future of the technology. So we'd like to push this out in a non-commercial way and get as many people, including transit agencies, involved so that we can move as fast as possible to deliver on this vision. Thank you very much.
down to 10 minutes. Good morning, everybody. I'm Al Chaffee. I'm with Plug Power. And as Jeff mentioned a little bit ago, China Energy is in his words, is the largest hydrogen company that nobody's ever heard of. We believe that Plug Power is the most capable hydrogen company that you've never heard of, and I'll explain that in a little bit. Who is Plug Power? Many of you know who we are, some of you don't. We are a leader in hydrogen and fuel cell technology. Our business, and we're about to announce results, and our revenue for last year is going to come in just north of $180 million. That is primarily in two areas: supplying fuel cell hybrid electric drives to forklifts, to material handling business, and also providing the fueling infrastructure that supports that. Those two go hand in hand. If you take anything away from this discussion today, understand that the infrastructure is closely related to the vehicle technology, and one doesn't happen without the other. You've heard everybody make that point very poignantly, and that is very key to Plug Power's evolution and to our claim that we have this capability, because we had to get into the hydrogen fueling business. We had to get into that infrastructure because our customers, you'll see in a moment, demand mission-critical type of operation. We cannot miss a single fill. We cannot go down a single minute. It just can't happen. A couple of numbers here. We've got 25,000 plus fuel cells operating in the field. We've accumulated over 200 million operating hours on those fuel cells. We have done to date 16 million plus, and we do like 15, 20, probably more now, it's more like 25, 30,000 fills per day. Individual fills into hydrogen tanks. We've dispensed in excess of 10 million kilograms of hydrogen in our existence, and that is going up by about 20,000 to 25,000 kilograms a day. Those kind of numbers, I haven't heard anybody in any forum that I've ever attended talk about those kinds of numbers. We believe we are by far and away, to what China is to Texas, that's what we are to the rest of the hydrogen fueling industry. We have that much experiential expertise, and we wear the scars on our back. This was not a road that was not bumpy. It was very bumpy. And what I'm going to talk to you about today, I couldn't talk to you about this a year ago. Right? It's just in the last year that these concepts have kind of come together. So some of our customers, okay, you see these names here. They're names that we all understand and that you all know. Amazon and Walmart are amongst our two largest. The contracts that we have with them, actually, and this is public information, they actually have warrants to buy certain percentages of the company. We are a publicly traded stock. Now, imagine a Walmart facility or an Amazon facility losing hydrogen fueling capability for half an hour, much less a day. That is impossible. It is not even part of anybody's consciousness. These folks here, and we're not just in material handling, we're also for goods distribution, we're also in manufacturing locations. Customers like BMW and Honda and Mercedes count us amongst their key suppliers. Every one of our customers operates on average north of 200 vehicles in their facilities. Now these vehicles don't consume as much hydrogen as a bus does, but we'll see that at scale, our solution will work just nicely. And it is mission critical stuff, okay? So just to tell you a little bit about what our Gen Fuel hydrogen solutions are, we provide all forms of hydrogen. We can provide liquid delivery, we can provide gaseous delivery, we can provide on-site steam reformation, we can provide on-site electrolyzers. The difference is that we can do this simultaneously. We can mix and match these technologies. You don't have to pick one. You can evolve, you can scale, and your costs are never stranded. And that's the difference. And by the way, we would love for the suppliers. We don't produce any hydrogen, we buy hydrogen. We have just surpassed NASA as the largest consumer of hydrogen in the US for fuel. We buy more hydrogen for fuel than anybody else does. So we've got lots of experience at doing this. So to the extent that the hydrogen suppliers decarbonize their hydrogen supply, we would welcome that, because our equipment is, it doesn't matter where the hydrogen comes from, as long as it meets the purity standard. There we go. So we've heard about the starter solution, okay? So let's talk about a starter solution. In the bottom left, you see a little photo of a gas tube trailer truck with a hydrogen dispensing station inside. Of course, our business is forklifts, so that was the most convenient photo I had. That can be most easily a bus. The most simple solution, as we've heard about talk today, you bring in a hydrogen trailer and you hook it up to local compression or storage and a dispenser. The simplest solution is to just go straight from the trailer to the dispenser, okay? If you want to completely empty that tank, because we're talking about pressurized gases here, you probably want to add some compression. That compression will stay behind and will be used as you expand the system. Now, the other item here that I want to specifically point out, is that little gizmo right there, the intelligent manifold. That manifold is also modular, and each section of that manifold occupies the same physical footprint as perhaps two adults standing next to one another. So it takes up very little footprint. But it allows us to accept hydrogen from any source simultaneously on site. So you'll see here I've got the fleet expansion, all right? If you're going to expand and you're going to go beyond a certain number of buses, and the next logical step would be to get delivered liquid hydrogen, as many folks have talked about here. Well, we can take that tube trailer and leave it in place, either expand the manifold or use existing ports that are on the initial manifold, and bring in a liquid tank with an evaporator. There's a photo of something like that, very similar to the photos you've seen, and all of this all works together. Our experience is this provides the lowest capital cost and the lowest per kilogram cost for the hydrogen fuel. That's today, okay? I'm very encouraged by some of the technology discussions that I've heard and some of the future work going on here. We have all the confidence in the world that the hydrogen supply industry will respond and will meet some of these $5 and sub $5 kilogram targets. And when that happens, certainly that, the dispensed at our equipment, we would see those same kinds of numbers. But the point here is that all of that compression and storage, should you install it, all of that manifold will accept different pieces. And that tube trailer now can stay behind as a backup system, because your liquid tank will need to have some maintenance. Your compressors on the liquid tank will have some maintenance. So to have the ability to build on the investment that's already been made, leave that behind to address the R that Jamie talks about in the PARSE acronym, about the resiliency and the redundancy and the reliability. This fits that, this accomplishes that. And again, our customer base, if you recall from that slide, they require nothing less. If we went in with something that didn't have virtually 100% uptime and availability of hydrogen. I mean, we write contracts where there's penalties on whether hydrogen is really available or not. And that includes downtime by our suppliers as well. So we scramble quite a bit to make sure that this equipment stays up and runs. So now you may talk about as you're going along, of course, you're running hydrogen buses. You realize how wonderful these vehicles are. They run in all sorts of weather. They run exactly on all the routes. You don't have to do any route planning. Am I going to have this size bus for this route and this size bus for this route? Just buy the bus and put it on the road. It'll work on every one of your routes. Same thing is true with our forklift business. Our customers realize tremendous productivity gains because now they don't have to plan for downtime of the drop off in performance as the battery discharges in the fork truck. They can use that fork truck just like they would a diesel or a propane powered fork truck. All of our facilities are indoors, so you can't use a fossil fuel powered fork truck. We replace battery electric fork trucks with a fuel cell hybrid electric power plant, and the productivity gain that they get is tremendous. Their operational lives are simplified to the point where they're seeing big productivity gains in their facilities. And customers like Walmart will rank order their facilities in terms of their productivity metrics. And every Plug Power enabled Walmart facility goes right to the top of that ranking. And so there's a benefit to the operators as well. They really do want to see that technology adopted. If I could advance, there we go. So now you're going to expand again, and just having a liquid tank isn't going to do it. Or perhaps you have a preference for on-site generation because you have access to very low-cost stranded wind energy or stranded renewable energy, or you have access to biogas, so you're going to put in a steam methane reformer or an electrolyzer. And I've shown here as only one of the two, because initially you would probably pick one of the two, but they can be blended. As I said, our intelligent manifold will blend all of these together, okay? This is a green solution, all right? And when we can get liquid hydrogen delivered from green sources, that'll be a green solution as well. But you can scale this up, and now you can see this is a solution where you can get up into the tens of buses, perhaps, and I'm being a little conservative here, but this will probably support 50 to maybe 75 or 100 buses. So now, you're really going, your entire fleet is going to be converted. You're talking about hundreds of buses. Now, you can take all of these, and again, I say one of the two, electrolyzer or reformer, it can actually be a blend of all of them. You can have multiple electrolyzers, you can have multiple liquid tanks, and all of the investments that were made along this journey stay behind. It is an additive, process. A starter set, theoretically, can cost $0 down. That has to come with some kind of a contract for supply of hydrogen, as some kind of a price, but that's more of a pay-as-you-go model, as Steve mentioned. For a few $100,000, we can probably get you started at a more modest hydrogen molecule cost. Those investments stay in the ground. These things will scale up to several $1 million. But our solutions are quite cost-effective because, I forgot to mention this, we have installed 80 hydrogen fueling stations of this kind. Anybody who's interested, I would invite you to tour a system that looks very much like this photo here. It's a reformer and a liquid hydrogen tank on site with a gas tube trailer section. It is, interestingly enough, the total hydrogen demand for that facility is about 400 kilograms a day. The reformer is sized for just over 200, and the liquid tank is supplying just over 200. So we're blending those sources of hydrogen so that there is no one dependency on one or the other. Again, the liquid pumps will need maintenance. The reformer will need maintenance. And having the ability to bring that gas tube up and to provide that kind of backup when they're both out is very important. Sure, I will get to this last item right here, and this is where we have all of our experience put together in one package. We call this the Janky Program. Our material handling customers and our manufacturing customers are very familiar with this. We will come on site and we will plan, design, permit, construct, commission, start up, load in and close out and turn over to you a station. We will also do ongoing maintenance and support. Many of our locations have on-site technicians. Our on-site technicians are there because it's just that critical. The lead time for this, literally, is about 16 weeks. If you've got a permitting process that takes a little bit longer than that, we allow about 6 to 8 weeks for the permitting. So after the permit's done, if we really had to, we can get it up and running in about 8 weeks. So I've heard talk about 3-year planning cycles and having to deal with your local utility. That is just non-existent in this world. We don't need to do that. And the last thing I'll leave you with, again, is that our customers depend on us for mission criticality. Your buses have to run, just like materials have to flow through an Amazon website, warehouse. And this is the kind of capability that we believe we can bring to the transit agencies. Thanks.
Thank you. Okay, so we have a few minutes. Instead of taking the moderator's prerogative to ask the first questions, I don't feel like I need to do that because I feel like the points that I wanted to draw out having to do with the complexity of building out a battery electric structure is maybe can be contrasted with the simplicity of a hydrogen infrastructure, but there are complexities with hydrogen. You've heard some of those too, because there are lots of options in terms of supply. International, there are lots of lessons to be learned internationally. The time to get started to build a station, whether it's a mobile or a temporary station, or actually a fast build station by a manufacturer who is mass producing stations. All of those options have kind of come out here a little bit. And so I'd like to just have the microphone ready. You're ready? Please fire it up.
Hi, Ray Pingle, Sierra Club. First of all, I would like to really commend the Hydrogen Business Council for their recent policy target of 100% zero carbon hydrogen fuel by 2030. So that's awesome. So from our perspective, I mean, fuel cell technology is good technology. It's all about the fuel. And there's good hydrogen and there's bad hydrogen. And so I'm very encouraged by basically all the vendors starting to talk about it, some moving more quickly than others. But I would just encourage the industry to really transition as quickly as possible to carbon-free hydrogen. And just one caveat on that is today, California's requirement is what, about 30 or 33% of the fuel has to be carbon-free. I can't imagine in the state of California with all the policy drivers and governor's executive orders and everything for reducing carbon that that's going to stand for a long time. So I would forecast that there will be initiatives in the next few years to gradually increase that. So I think it won't even be optional. So I just want to really encourage the industry to move as quickly as possible to carbon-free hydrogen.
Thank you. I agree with you. And you will note that our target for 2030 is really faster than decarbonizing the electric grid. Both are useful for producing hydrogen, of course. Another question?
Mark Montgomery with Omnitrans. Question, one of the challenges of using a lighter than air fuel is the repair garage. And us transit agencies have to deal with the repair garage. So in your assessment with a hydrogen plant at a transportation center, do you take into account the necessities for outfitting the garage for that lighter than air fuel?
I'll handle it. Yes, we do. Our dispensing stations are routinely operated indoors inside of distribution centers. So we're very experienced with that. There are emerging hydrogen fuel standards amongst the various safety agencies like UL and CSA. We comply with all, we carry all of those regulations. We've got all of the fire detection and suppression and things that you might want to see with that. That's a much longer discussion. I'd be happy to talk to you about that after the session.
I would venture to say any of the vendors up here are familiar with that and would be able to help you with that. So that's kind of standard practice for what Trillium and Air Products are doing at Okta, what we've done at SARTA and other places. So it's pretty standard in the industry now.
Good.
And if I can just add to that, if you're already a CNG property like Omnitrans, you're already most of the way there.
Good. Thank you.
Yeah, Jamie Levin with CT, and regarding that last question, we're involved in making major transformations of existing facilities at diesel fueling and CNG facilities and interfacing that with the station and the vehicle needs. There's some complexity to bring vehicles, fueling, and retrofitting maintenance facilities and making sure it all works as it should. And Orange County will be a perfect example for you to see that very shortly. We're almost finished with the work there. Two questions for all of you. I don't think you touched on, across all these different applications, the standardization of fueling, that in all respects, whatever the delivery system, you can fuel any of the buses. That's important to emphasize. And Jeff, I wonder if you could comment, there have been issues of undergrounding liquid natural gas and what the differences might be with hydrogen undergrounding. But first, if you could just acknowledge the standardization across all these systems for vehicle fueling.
Sure, the fueling for buses, most folks are doing H35 or 350 bar fueling, and as long as you have kind of a standard receptacle, standard nozzle, you can fuel any bus with that receptacle and nozzle. So you can take a bus from one transit agency to another as long as they're fueling 350 bar, and it's quite standard.
Yeah, and I'll just mention too that in terms of third-party certification of equipment, we announced last year that we have a UL-listed fueling package available for the U.S. market, which goes a long way towards assisting with getting approvals for installation because it is third-party listed.
Ryan, you want to take one?
The second question was?
Specific to me. Yeah, so thanks, Jamie. So on our technology that we're working on right now, as I understand, there's been a couple applications at transit agencies where they did LNG underground. And some of the issues, obviously, one of the big concerns is leakage and also interfacing the pump to the tank. And obviously, in the case of hydrogen, we're looking into things like the Water Board and various other agencies that might have concerns about placing a tank underground. Also, we're working on with best-in-class partners, including engineering teams and companies, to do the reference design I mentioned earlier. But within our Beijing division, they actually have some new materials where we're actually going to apply a coating to the outside of the tank for damage, scratch protection, moisture, et cetera, to mitigate any issues with leakage. Relative to the interface piece, we actually have filed some IP in conjunction with our partners so that, because especially as you contemplate very large bus fleet installations, you may be talking 8,000 kilograms, a 300 bus fleet, 30 to 35 kilograms per bus at 85% utilization. You're talking 8,000 kilograms per day. So, one of the things as we think about our pump, even if it's maintenance cycles once a year, you can't have a situation where you pull out the pump to do maintenance and now you lose all of that, you vent all of that hydrogen out. So those are all the things we're thinking about, and basically a interface that prevents such a thing. And also, of course, in the case, as I understand from those prior experiences with LNG, is some contamination getting to the interface between the tank and the pump. And with liquid hydrogen at such a high purity, you're not going to have contamination or raw material that's going to contaminate that interface.
I want to maybe clarify a question that Ray raised. The state does not just have the electricity grid renewable target. We also have AB 1505, which is the transportation hydrogen renewable target, which is also 1/3 by 2020. And last year or the year before, we've already met that target. So I just want everybody to know it's equally clean.
Thank you, Yachin. I think we're out of time. David, did you have a question?
I do, and an observation. I can tell you as a bus manufacturer that one of the things we haven't spoken about yet is that Steve opened the conference yesterday with the weight of gasoline or liquid fuel compared to a battery. I can tell you that we can build a fuel cell electric bus with further range than a battery electric bus because of weight. So I think that's a big deal. And where my question is going is that's going to be a big deal in commercial trucking. And I'm curious what the panel members have to say about the future of commercial trucking, because that's where we're going to get our volume for hydrogen, which will help us in transit.
I think particularly in the drayage application, it's a great use for fuel cell technology. In general, in that application, you're going 100 miles or less back and forth to your distribution center, and I think that's perfect, as Toyota and Kenworth and others for fuel cell electric technology. As you get to longer range, I think the bigger challenge is getting enough hydrogen on and balancing that weight, and I think that's why some are looking at higher pressure hydrogen or 700 bar hydrogen to meet that need.
Yeah, and I'll just say that we're working with Nikola Motors on their Class 8 truck rollout, and they pre-sold thousands of trucks, including 800 to Anheuser-Busch, because they're offering a $1 per mile lease that's cheaper than any diesel lease that you can get today, and that includes the fuel. So, when you talk about, that application, when they get the truck right and we get our fueling stations in place at strategic locations, it will be, a real kind of breakthrough for getting hydrogen propagated at scale throughout the country, as you said. That's really where, that's going to help drive scale. Exactly.
So I would tell you that delivering energy, and I'm an electrical power engineer from way back, so this goes against everything that I was ever taught, but delivering energy via electrons over copper, over conductors, and you look at the energy transfer rates as opposed to delivering energy via a chemical bond, either a petroleum product or alcohol or hydrogen or any other kind of fuel, there just is no comparison. So in applications where you have high utilization and high energy density of usage, chemical bonded type of fuels are going to outshine delivery by electrons. And consequently, when the equation tips in favor of lighter duty or less intense energy content, then your delivery of energy via electrons has got several positive advantages. So we see a role for both, and I think to your point, in the heavier duty and the higher duty cycle, a chemically bonded fuel will lend itself more to that application.
So we need to wrap this up. I would just like to close by saying, I know as a transit operator, you see a lot of complexity lying ahead, a lot of things that have to be evaluated. There are organizations and people, these panelists obviously are each experts and their companies are. I see Bill Elrick in the audience here, who leads the California Fuel Cell Partnership. Lauren Skyver, Sunline's a member of ours. She's leading the ZEBs group, the Zero Emission Bus Resource Alliance, I think it is. Intending to be also a kind of a technology neutral battery and fuel cell oriented group. We would love to see you help build our strength for our advocacy work among these organizations. The California Hydrogen Business Council is the one that can lobby and advocate. And we have a group that's leading that effort in transport. And so I urge you to keep your options open, evaluate fuel cell buses. Don't assume that just because most of the zero-emission buses on the road today are batteries, that is the way of the future, the only way of the future. I don't think that's the case. I hope you've heard enough information from Jamie's panel yesterday and from this one to realize that there's a lot of credibility and a lot of experience in the sector. Thank you very much for your attention.
We are now moving to our keynote presentation and also an awards presentation.
Good, thank you. Good, thank you. Well done. Thank you very much. It's good working with you.
But we are. You can come.
All right, we're going to get started with next panel in a minute, but first wanted to give you a little background and then make an awards announcement. And again, I'm Richard Corey, Executive Officer, Executive Director of the California Air Resources Board. Again, appreciate you all being here and having a discussion over the last 2 days. So really, over the last 2 days, as you've noted, we've been learning a lot of valuable experiences about the challenges that transit agencies can face with the transition to zero-emission bus fleets. In fact, I just heard some additional discussion here just a moment ago. We all understand this is going to be, it isn't easy, and there's some challenges, certainly some opportunities, but I was impressed to learn about Shenzhen experience to electrify more than 10,000 buses. I think it's actually 17,000. We heard from Mr. Ma about the challenges they faced and resolved to charge a large fleet of buses, the infrastructure element, obviously. And we hope to partner with all of you to provide the same great outcome for California. And as we learned from our speakers, the first step is really planning. And with that, planning is crucial to ensure successful zero-emission fleet deployment. Careful planning is also critical for the infrastructure scale-up to ensure such scale-up can leverage investments at the early stages. We also understand that the initial costs at the beginning of the transition to zero-emission fleets can be high. However, the benefits of transitioning to zero-emission fleets are also high. They're high as well. Zero-emission buses will not only bring clean air to local communities, but also create clean jobs in our state and throughout the state. And in last December's joint meeting with the California Transportation Commission and the Air Resources Board, we heard strong support from many board members on the importance of transit for providing mobility to all Californians by improving access to efficient system, especially for low-income communities. And I touched on this yesterday as well. SB 1 has provided historic increases in transit funding, unprecedented based on historical experience. We also support public transit, and we need to work collaboratively to counter the declines in ridership as part of meeting our sustainability goals. A transition to 100% zero-emission fleets needs commitments and hard work from all of us. And clearly that's the agencies, it's the funding, it's the process, and it's going to be important for the next many months and years to effectively work through this transition with you all. So I hope you already got the chance, and I think many folks did, to look at the zero-emission buses that were outside the building. We have both battery electric and fuel cell, just as was talked about a moment ago on the panel, fuel cell electric buses, ranging from a 25-foot small bus to a 62-foot articulated bus. They're built by various manufacturers. Some are in California, such as BYD, El Dorado, National California, Green Power, Phoenix Motor Cars, and Proterra. Some of these manufacturers do not just have a production plant in California, but also have battery production plants here as well. So altogether, they provide better paid green jobs to our local communities while providing clean buses to operate in the hearts of our communities. We have a number of transit champions taking the lead of transitioning to zero-emission buses. And I mentioned this yesterday, and clearly many of them are here. Each of them has its own unique contribution to the advancement of the cleanest technologies and to the improvement in air quality. These transit agencies are the pioneers in addressing fuel cell maintenance, electric drivetrain maintenance, electricity rates, charging standards, education, training, developing new technologies, and resolving some other unforeseeable issues in transitioning to new technologies. We very much appreciate the vision and the effort from forward-thinking leaders of these transit agencies. And as we know, taking the lead isn't easy. And we're fortunate to have visited some of them. In fact, I've been able to visit several. Would like to share with you some of the lessons we've learned or the experiences. For example, AC Transit currently operates 13 fuel cell electric buses. These buses were placed into service in 2010 and as a demonstration project. Last year, 5 of these buses exceeded 25,000 hours of continuous operation, 25,000 for the fuel cell power plants, which is the ultimate goal based on the Department of Energy's target. AC Transit is also has its own in-house training program now, and you'll learn more from them this afternoon in session 6. Sunline Transit was the first transit agency to use fuel cell technology starting in 2000. They continue to deploy new technologies over the years. Between their Generation 1 and Generation 2 buses, they were able to reduce 5,000 pounds of weight. Today, they have their Generation 8 fuel cell electric buses in their fleet and just received another brand new fuel cell electric bus funded by CARB, which is displayed outside. Sunline has also established a training facility, the Center of Excellence in Zero-Emission Technology, to provide zero-emission bus workforce training. The Center for Excellence has a booth right outside our auditorium here, so I hope everyone has a chance to visit it. The list is very long, goes on, and I don't want to leave anyone out, but I could probably go on really all day in terms of the leaders and the actions that different agencies have taken. Certainly Foothill Transit, San Joaquin Regional Transit District, Long Beach Transit, LA DOT, LA Metro, and Orange County Transit all deserve to be called out as well. Finally, we have this amazing articulated bus from the Antelope Valley Transit Authority here today. Like some of the success stories we've heard, Antelope Valley Transit Authority's leadership demonstration comes from local support. Local support is critical for this transition that we're talking about. Its board has been instrumental in steering this transit agency toward a sustainable future. Antelope Valley is part of the movement in the Antelope Valley to undertake projects that further renewable energy technologies and reduce our dependence on fossil fuels. The authority also has been installing solar canopy as its facility since 2004, and in 2017 became the first transit agency to operate a 60-foot, as I noted, articulated battery electric bus. We're also very excited that the agency is leading the innovation and will become the first California transit agency to have 100% zero-emission buses this year with their 85th bus fleet, or 85 bus fleet. In order to achieve such a goal, the agency has been innovative in finding funding opportunities, developing workforce training, investigating their technology options, and examining their charging strategy and routes. Their experience does not just benefit our transit community, but also contributes to the advancement of zero-emission technologies and the broader market for zero-emission heavy-duty vehicles, which is really where we all need to go as a state and nation. To show our deep appreciation, I'd like to present the Leadership Appreciation Award to our co-host, Antelope Valley Transit Authority. So with that, ladies and gentlemen, please join me in welcoming Mr. Macy Ashati, the Executive Director of the Antelope Valley Transit Authority. Macy. We've got a plaque for you here, and a few remarks if you'd like.
Our chairman was supposed to be here to make some remarks, and you would have been really entertained and enjoyed that. He's a great speaker, and unfortunately has had some health issues and wasn't able to make it today, so you're stuck with me. I can't take any of the credit for what this remarkable agency has done. It's been, and some of the staff that's contributed to this from day one are out there, and I'd like to acknowledge them. Norm Hickling, our Director of Strategic Planning and Development. Mark Perry, our Director of Facilities and Maintenance. Mark. Judy Fry, our Director of Finance Administration. These brave and courageous people have been there from day one. Judy's gotten us tons of money. Len Engel, I think the Executive Director who led all this when it happened, is out in the back. Len? So the credit goes to them. But I do want to tell you a little bit about the journey. The journey to 100% emission fleet has been gratifying for this agency. It's been exhilarating. It's been unifying. And at times it's been challenging. But the challenges have quickly faded away as we considered what the stakes were and how much we had to gain. As we noted earlier, in 2004, we took our first step, a small but significant one, that spoke of things to come as we became the first transit operator to install a 175,000 kilowatt solar system on our facility to help start powering the buildings. That was enough to provide 15% of our energy needs, but in 2009, building on this success, we had another 590,000 kilowatt hours of solar panels, which got us to about 75% of our facility needs. Encouraged by our success in producing our own energy, in 2016, the board of directors for the Antelope Valley Transit Authority set a goal to become the nation's first fully electric fleet, which in 2016 was quite a remarkable thing to ambitiously commit themselves to. The board's decision provided the agency with a clear direction and sent a strong message that AVTA is serious about its intent to be 100% green. When completed at the end of this year, the electric bus fleet conversion project will create a smarter, greener, more interconnected system. By using groundbreaking zero-emission battery electric bus technology and wireless inductive charging technology, we're really going to be able to run our bus fleet 100% of the time with very little depot charging. Back in 2014, we installed the first couple of wave chargers that were 50 kilowatts, and we thought it was a pretty big deal, or 2017. We thought it was a pretty big deal. But just last month, we opened up at our Stephen Owen Memorial Park Transit Center 250 kilowatt chargers. We got 3 pads on the ground, each capable of doing inductively 250 kilowatts of charge, which translates into about 14 miles. Yeah, 14 miles per 10 minutes of charge. Again, a revolutionary thing. Those pads, by the way, were supplied by Wave. So we've had a lot of successes, a lot of firsts, and there's a lot of people to thank. And I want to especially call out the Federal Transit Administration, California Department of Transportation, to their transit and intercity rail program, which I think funded us 3 years in a row, kind of an unprecedented event. And that got us our buses purchased and helped us with a lot of our infrastructure needs. And most of all, I want to thank CARB. I definitely want to catch up with my notes because I want to be very accurate about all the things we have benefited from CARB's leadership. So forgive me again, I was pressing a service at a very late date. Sorry. But we're almost there. Yes, and of course, California Air Resources Board, whose visionary regulatory efforts established the HVIP fund, helping to equalize zero-emission bus pricing, and whose courage and unwavering commitment to air quality nurtured and encouraged a single bus company that could. So our thanks and our debt of gratitude to the California Resources Board for what they've done for all Californians. And whether you know it or not, our children and our grandchildren's lives will be greatly enriched by breathing cleaner air and moving towards a more sustainable future as a result of their courageous efforts, and sometimes against the will of a lot of people. So thank you, CARB, Air Resources Board, for your efforts, and thank all of you for your support.
Now we'd like to invite the entire AVTA team up here for a photo op. And then that also includes you.